Good afternoon, my ECO 3311 students. We did part of chapter 4 already. I recorded the recordings for those chapters are in Canvas. Make sure you watch. Make sure you guys are watching those videos. Because next week I'm just gonna, because since this class is hybrid, I may just record most of the lectures because it's the same thing. While you can come on Zoom live, you can as well watch the video after I've already recorded them. So make sure you're keeping track with those videos. They're up at under course modules. If you scroll down, you're gonna get to those video recordings. So this is gonna be the last segment of chapter 4, which I wanna record now. So let me share my screen. So we've been talking about the time value of money. We talked about simple loan, fixed payment loan, and coupon bonds. So let's kind of continue along the dimension and finish this chapter. And then I'm going to be assigning homework 2 and quiz number 2 this evening. Then tomorrow I'm going to be recording chapter 5, okay? Because your midterm exam 1, which has been shifted to next week on Monday, is going to be chapters 1 through 5. 1, 2, 3, 4, 5, and chapter 19. So those are 6 chapters, I mean. Okay, so let me share my screen and we wrap up this chapter. Okay, so we covered quite a bit of this, quite a bit of chapter 4 now. So we talked about coupon bonds. So this is what we're talking about with the data. I talked about some relationship between interest rate, price of bonds, the yield to maturity, which is the bond interest rate, and face value. So you think about a coupon bond with a face value of $1,000. This is a summary of what we talked about. So it's a coupon rate, which is your little c, is 10%. And then we're saying this bond has a face value of $1,000. So we were trying to get the relationship here. So the first relationship that we talked about was that anytime the price of the bond equals to the face value, okay, this is actual data. The bond interest rate or the bond yield must always equal to its coupon rate. And that occurs right here. See this row here that I'm cycling? See, when the price of the bond is $1,000, that is equal to the face value, which is also $1,000. So anytime the price of the bond is priced at its par value, at its face value, the interest rate or the yield, which is 10%, so is going to be equal to the coupon rate. So the coupon rate is 10%. That is true always. And then we also say that when the price of the bond is greater than the bond face value, this implies that the interest rate on the bond is going to be less than the bond coupon rate. And you can see anytime the price, there are two prices of these bonds which are above the face value. If the bond price is $1,200, for example, you see that price is above the face value. So that means the price is greater than face value. So it is always going to be the case that the interest rate or the yield on that bond will be less than the bond's coupon rate. That is always true. And then anytime the bond is priced below its par value, price is less than face value, we say that the interest rate on this bond is going to be greater than the bond's coupon rate. So anything above below $1,000, like if the bond price is $900, see that $900 is below the face value of $1,000. So that means the price is below our face value. So the interest rate, see, is going to be more than the bond's coupon rate. 11.75 is greater than 10%. And the same for when the price is 800, see, because this price is less than the face value, the bond interest rate is going to be more than its coupon rate. And then the last observation that we can see from this table that we also talked about is that when the price of the bond increases, the interest rate on the bond decreases, and vice versa. In other words, the bond price and bond interest rate are jointly determined, but they're inversely correlated. So you can see from this table, as the yield to maturity rises from 7.13 to 8.48 to 10 to 11.75 to 13.81, what do you observe on this other column for price of the bond? The price of the bond will be declining. So anytime the interest rate or the yield to maturity increases, bond price falls. And the converse is true. If the yield to maturity falls, if you're going up, the bond price will be rising. Those are the relationships I wanted to talk about. I want to talk about, there's a specific type of a specific type of coupon bond. That specific type of coupon bond is what we call consol or perpetuity bond. So back in the days, this started in England, the UK. They wanted, okay, so we talk about consol. Consol is also known as perpetuity bond. Perpetuity bond. Perpetuity basically means what consol basically means. This bond, this is a special type of coupon bond which pays coupons forever. So there's no end date. This bond has no maturity date. Forever or indefinitely. And the formula is very easy. The formula for a perpetuity bond is that the price of a consol, we put little c here to re-emphasize that this is the price of a consol, is given by, you take the price of a consol equals, you take the bond's coupon payment, C, divided by the interest rate on that consol, or the yield on that consol. And by the way, this is also the formula that we use for calculating the current yield on the bond. Anytime I ask you a question on the test that calculate, like if say the price of the bond is 1,000 and the bond has a coupon rate of like say bond is paying a coupon of $100, then I ask you to calculate the current yield. You're just gonna put $1,000 here for P. That would be equals to, if the coupon payment is $100 divided by C. So if I cross multiply, you get 1,000 IC equals to 100. Divide both sides by 1,000 by 1,000. You see this is going to be 0.1 or 10%. So the yield, the current yield on the bond would be 10%. It's the same formula we use for calculating the current yield on the bond. So as I told you, I promised you the other time that I don't like writing formulas for you to memorize, okay? I want to explain why this formula is coming from. Why do we write the formula for calculating the present value or the price of a consol like this? So let's get to work. Let me show you guys how to derive that formula, where that formula comes from. It's very important because I don't want you to guys memorize formula just to pass my test. I just want you to actually understand most of the formula I write on the board. You must understand where it's coming from. That is most important thing, so that in case you forget one day, you can derive it yourself, because that means you've understood the concept very well. Okay, so let me create a space here, and then we can talk about how we derive that formula. Okay. Okay. So because I can't remember the coupon bond, the formula for the coupon bond is at the present value. Let me maximize my screen here. So the price or the present value of a coupon bond is given as C over 1 plus I plus C over 1 plus I squared plus C over 1 plus I to the power 3 plus, okay, so if this bond is a finite bond, if this bond has got a maturity date, you would put like dot, then the last is going to be coupon here would be C over 1 plus I raised to the power n. Then on maturity, you also get paid the face value back, which is 1 plus, the discounted value of that payment will be face value F divided by 1 plus I to the power n. This is for a normal coupon bond. But we are saying that a consol pays coupon forever, meaning that there's no end date. Okay? Something that pays you forever. If you buy, it's going to pay you what? But if you think about it, the present value of something that is coming very late in the future is almost close to zero. But anyway, that we know. So for consol that we're talking about, or perpetuity bond, the price or the present value is going to be just written as C over 1 plus I plus C over 1 plus I squared plus, this is going to go forever. There's no end date. Or if you want to put an end date, you could say plus C over 1 plus I to the power infinity. because that's what we mean by indefinitely, infinitely large. So if something is going to infinity, if there's no end date, if a bond does not have maturity date like a console, that means you'll never get a face value back because the bond continues to pay you coupon forever. Okay, so there's no face, you're not going to get the face value back for such type of bond. The face value is only paid to you on maturity of a bond. But because this bond called console does not have a maturity date, there's no reason for you to receive the face value back. Okay, so the bond continues to pay you console forever. So what we're going to do, yeah, just like we said, we're going to say let R be equals to 1 over 1 plus R. Then we're just going to write this as P equals to C. The first term becomes CR squared, CR to the power 3. And we're just going to put dot, dot. That means it's going to infinity. Okay? And then I can factor this. I can write this bond as P equals to CR. If I factor CR out, the first term here is going to be 1. Second term is going to be R. Because CR times R, that's CR squared. Plus R squared. That gives you this term here. Plus this is going to go like that. Okay? So remember, you know this formula already. Okay? We said, okay, let me duplicate that. So we say that, so we have P equals to CR inside 1 plus R squared plus R power 3 plus this goes indefinitely. This is a formula that we in the handouts. This is a geometric progression. The sum of this type of series is this is exactly what we did in the handout, where K starts from 0 to N, R to the power K. We say this is going to be equals, if K is 0, that is 1, because any number to the power 0 is 1. Then the second member of the series, because we are summing them. So this is summation sign. R squared, R to the 3 plus, see, up to like R to the power N. But because, so if we say that this is N become infinite, this is going to go forever. And we already said that for a finite series, we did the algebra. The sum of this type of series is going to sum to 1 minus R to the power N plus 1 divided by 1 minus R, okay, minus 1. No, just that, okay? Yeah, because, you know, this is started from 0. So now I want you to think critical about this. If N, because the perpetuity bond is what is going to pays you coupon forever. So that means if N goes to infinity, the sum of this series is going to be equal to 1 minus 0 divided by 1 minus R, which is just going to be 1 over 1 minus R. If N goes to infinity, it means that R to the power N plus 1 is going to go to 0. Because R is a fraction. It's a proper fraction like 1 over 2. If you continue raising 1 over 2 to a higher power, the result gets smaller and smaller. So if N gets large, goes towards infinity, any proper fraction you raise to that larger power is going to go to 0, meaning that this part is going to be 0. So that means that means the sum of what you have in the bracket for perpetuity bond is just going to sum to that, because it's a perpetuity bond is pays you coupon forever, indefinitely in perpetuity. So that means the price then is going to be equal to CR in bracket is just going to be 1 over 1 minus R, because that's what the sum of this is. Okay, so this becomes really easy now. So if we are saying P equals to CR, okay, inside 1 over 1 minus R, we can write this as P equals to, you can distribute this CR here, so that becomes C inside R over 1 minus R. But what is your R? R is 1 over 1 plus I. So we can write this as P equals to C in bracket 1 over 1 plus I divided by 1 minus 1 over 1 plus I. So you're going to write that. Well, now when you do a little bit of algebra here, so you get C here in bracket. So the numerator is 1 over 1 plus I. Then we are dividing by. So now we need to combine this under common LCM. So the LCM, the lowest common denominator is 1 plus I. 1 plus I times 1, that's going to be 1 plus I. minus 1 plus I divided by 1 plus I is 1. 1 times 1 is 1. Okay, so this, you get P now equals to C inside 1 over 1 plus I. Okay, so this is like 1 over 1 plus I divide by, you can put a division sign here. Divide, okay, so the 1 is going to cancel here. So you're going to get divide by I over 1 plus I. Okay, and you guys know that if you're dividing at like X over Z divided by P over J, this is the same thing as X over Z times J over P. You invert this, you change it to multiplication. So the same thing here, so that P is, oh, sorry. So the same thing here, so P is going to be the same thing as C inside. You can write this as 1 over 1 plus I times, this goes up on top, 1 plus I over I. And then this guy cancel. So you see, so therefore, the last is, you know that P is going to be the same thing as C over I, over the yield. All right, well, P equals to C over I. That is the formula for perpetuity bond that we wanted to derive, right? That's it. This formula here. So that's how you derive it. Very easy. Okay. So you can calculate always the price if I tell you that if this is a formula, price equals to C over I, interest rate, and you can put C here and P, put a little subscript here to re-emphasize that this is the price of a console, and that's the interest rate on that console. Okay. So for example, you could say if the bond sells for $1,200 and pays a period coupon of, say, $200, what is the current yield on this bond? This is the formula that we use for calculating the current yield on a bond. So that's very easy. So you just substitute in this formula. If the bond is selling for $1,200, that means P is $1,200. So substitute there $1,200 must equal to, or it pays you a period coupon of $200. So the C here is going to be $200. Then we're solving for the current yield on that console. So you cross multiply. You're going to get, you get 1,200 multiplied by I times C must equal to 200. So this is dollars, this is dollar. So divide both sides by $1,200 by $1,200. It is cancel. So you get 201 over what? 1 over 10. No. This is 12. It's going to be 1 over 6. So what is 1 over 6? Yeah, so we check out 1 divided by 6, 0.1. So the interest rate on this, the current yield on this bond is going to be 0.1667 or 16.67%. So it's pretty straightforward. Okay. So let's make more progress. So now the last type of bond that we're going to talk about. So now up to this point, we have now established, know how to calculate what. So let me keep what about here? Let's open up more slides. So the next type of bond that we're going to be talking about is the discount bond. Because, okay, so the four, let me read, four credit market instruments that we talk about credit market instruments. We talked about simple loan. That one is done. We talk about coupon bond. That is done. We talked about fixed payment loan. That is done. So now let's look at the last credit market instrument, which is a what? A discount bond. Okay. So with a discount bond, what's a discount bond again? Let's define it here. A discount bond is also called zero coupon bond. Zero coupon. So a discount bond is sold to you, is sold at a discount. When I say sold by discount, it means the price is always below the face value. But on maturity, you get paid a full face value. So let's say, suppose P was 900. And let's suppose the face value of this bond is $1,200. So the reason why this is called discount, how you make money, let's say this bond matures in 1 year. Okay. So that means you're going to buy it for $900. But after 1 year, when it matures, then the government would that issue that bond is going to pay you $1,200. So that means you would have made $300 in what? In profit, in interest. Okay, so let me say that again. A discount bond is also called zero coupon bond. You don't get coupons from buying a discount bond, but that bond is purchased at a discount. But on maturity, you get paid a full face value of the bond. So you make the money from the difference on the purchase price and the face value that you're going to receive on maturity. So the formula for the discount bond is quite straightforward. Is that the interest rate on a discount bond, you take the face value of the bond minus the bond's price or face value divided by the bond price. Very simple. Okay. For instance, if a bond is sold at $900, but as a face value of $1,000, then that means the yield on this interest on this discount bond is going to be face value minus price over price. Very straightforward. So this is going to be $1,000 minus $900 divided by $900. So this is going to be, the numerator is going to be $100 divided by $900. So 1 divided by 9, that interest rate is going to be 0.111 or 11.11%. Okay, so it's very straightforward. Okay, but if we are saying that sometimes we want to feel, if I ask you to calculate the present value of any discount bond, please don't substitute it directly here. So because this formula is written on the assumption that any particular discount bond you're looking at matures in 1 year. But what about if a discount bond matures in 3 years? Okay, the present value is going to be different. Okay, so what we need to do, you need to make P the subject to be able to calculate the present value. So just 1 second, again, more slides here. Okay. Okay. All right, so let's get rolling here. So what we're saying is that if the formula for since the discount bond is written as I equals to F minus P divided by P. The first thing we want to do, we want to make a P the subject. So I can write this as I over 1 equals to F minus P over P. So if I cross multiply, you can write this is going to be the face value is going to be equals to, face value minus P must equal to PI. And then I can collect terms in P on one side. So I can write this as P plus PI equals to F. If I add P to both sides, an equation where P becomes positive. So you isolate F on one side. But now P is common. You can factor this out. So you get P inside 1 plus I equals to face value. So if I divide both sides by 1 plus I, 1 plus I, okay, so you get P equals to F over 1 plus I. So this formula was written on the assumption that the discount bond matures in 1 year, because this is the same thing as 1 plus I to the power 1. But if I ask you to calculate the present value of a discount bond that matures in 3 years, you need to say P equals to F over 1 plus I raised to the power 3. If that discount bond, you see that? So it depends on the year to maturity. This is written F over 1 plus I because we're assuming that the bond matures in 1 year. But it matures in 10 years, you have to, the power here is going to be 10. Okay. So that's so and we can do an example. We can say example. Calculate the price. Remember, the price of a bond is the same thing as the bond present value. Present value of a discount bond with a face value of $1,200 and yield to maturity of 5% and maturing in what? Maturing in 7 years. Okay, so here solution. We know that the present value, you have to write the formula as F over 1 plus I, because this bond matures in 7 years, it's going to be raised to the power 7, which is just going to be, the face value is 1,200 divided by 1 plus, interest rate is 5%. 5% is what? 0.05 in decimal, but raise this to the power 7. So the present value of this bond is going to be 1,200 divided by 1.05 raised to the power 7, which is the same thing as 1,200 times 1 over 1.05 raised to the power 7. So what you're going to do in your calculator, use scientific calculator. Do 1 divided by 0.05 and raise that answer to the power 7. So you're going to go like 1 divided by 1.05, enter. We're going to raise that answer to the power of what? To the power of 7. Okay, you get 0.71, whatever, then times 1,200. Okay, so this bond, the price of this bond is going to be $852.82. That will be the price of that bond. Okay, so that's pretty much it. What a discount bond is, it's quite simple. Okay, we did console already, and that's a discount bond that we're talking about. Okay, so now the last part of the segment of this chapter that I want to talk about. Okay, right now, you know to calculate the present value, future value, stuff like that, you know, of a discount bond. of a coupon bond of console, you know how to calculate the present value of a fixed payment loan. You can figure that out. You can calculate. I showed you everything. But that's not going to be the end of the story. The story that you're asking yourself, if you ever buy bonds like a coupon bond, how do you actually get paid? Okay? Because I just showed you this. Oh, here's how you calculate the present value of a bond, future value. But I've not told you how you're going to make money. Okay? So we're going to talk about the distinction. The next thing we're going to talk about here, which is very, very important, is going to be the distinction between what we call interest rate and the rate of return, capital gains and the rate of return. See that subheading there? The distinction between interest rates and return. Okay. Now, before I talk about this, I wanna open one slide and kind of discuss it a little bit. Let me go back here. Okay. Okay. So, the first thing I want to tell you, if we say you are buying let's say for coupon bonds, for example, or for any bond, okay, the time to maturity which we call N, may be different from the holding period. What do we mean by this? So if you go and buy a 30-year US Treasury bond, 30-year means the bond matures in 30 years. It doesn't mean that you should be in prison with that bond for 30 years. Keep it for 30 years. No. As a matter of fact, you can buy a 30-year US bond, Treasury bond, today. It matures in 30. Then you turn on and you can only hold it for 6 hours or 6 years, six months or 1 year and get rid of it. So you can only hold that bond for 1 year and sell it. Okay, what do we mean when you buy a bond? What are we talking about here? I want you guys to understand. A bond is basically just a piece of paper. A bond is an IOU document, like this piece of paper. So an IOU document in the sense that when let's say you go and buy a $10,000 US Treasury bond that matures in 30 years, the US government is going to issue you a certificate. It's an agreement. They're going to sign off on this document saying that John has lent $10,000 to the US government. His money is going to be paid back in 30 years with interest. So if it's a coupon bond and you spend $10,000, let's say it's going to be paid in, let's say it's a 10-year bond. Then the government might say you spend $10,000 in. So the government might say every year you're going to be receiving a check of 10,000, sorry, 1,000 for 10 years. And then on maturity, you're going to get the face value of that bond back, which might also be $1,000 or $8,000, whatever it is. So if you honor the terms of the document, you bought a 10-year bond and you hold it until maturity, that means you never sold it. You honor the terms of the whatever until maturity. Okay, so here's the deal. If you buy a bond and hold on to it until maturity, that means you never sold it. Point one. The rate of capital gain, I'm going to talk about what that means, from this investment is 0. That means you're just going to be collecting your coupon payments every year for 10 years, if it's a 10-year bond. And then on maturity, not only do you get the last coupon payment, you get the face value paid to you on maturity as well. So that means you have never sold the bond. The rate of capital gains comes in when you decide to get rid of your bond before maturity. Okay? So 2, if you sell the bond before maturity, before it matures, let's say you bought a 5-year government bond, a 10-year government bond before it matures, then the rate of capital gains, may be 0, greater than 0, or less than 0, meaning it's negative. Okay? So I want you to have again. So when you buy a bond and the government says that the bond is as a yield, the interest rate you're going to be earning on the bond is 10%. That the yield to maturity is not the same thing as the rate of return. The rate of return on a bond investment has got 2 component parts. Let me show you this. So let's talk about the return. What you can call it the return, because that's what you're interested in, the return on a bond investment. In fact, this is not only restricted to bond. Any investment out there, the rate of return has got 2 component parts. I'm going to give you several examples on a bond investment. Has 2 parts. So the return, let me first write the formula, is going to be calculated as the guaranteed payment C of the as a share of the purchase price plus the rate of capital gains, which can be written as PT plus 1, or let's say PT plus N minus PT over PT. So this last portion here, this is what we call the rate of capital gains. This guy here, this is the guaranteed what? Payment, coupon payment. And when it comes to bond investment, this is the same thing as the yield to maturity, the current yield on this bond. Because remember, we talk about the formula for current yield. We say for perpetuity bond, we say P equals to C over R, meaning that if I cross multiply, the current yield on this bond can be written as C over P. So C over P here is the current yield on the bond. Okay, every investment, not even bond investment, has got 2 component parts. It has got the rate of capital gain and the payments that you get from holding that asset. So before I even talked about go and do example on the calculating the rate of return on a coupon bond investment, let's talk about other investment. Okay, let's how to calculate the return on other investment. I'm going to do 2 examples first before I jump on bond, so that you get to know what it is. So example 1. I say, suppose you purchase a restaurant, This is not a bond. You bought a restaurant in San Marcos for $200,000 on January 1, 2025. So throughout 2025, you made a profit selling food in that restaurant equals to $20,000. profit you made selling food throughout 2025. And then let's say on December, that just after 1 year, December 31, 2025, when towards the end of the year, you decide to sell the restaurant. You sell the restaurant for $250,000. And then I'm going to ask you, Roman A, what is the rate of capital gains from this investment? Two, what is the rate of return after you sold this restaurant? See, now, here's how we go about it. So calculating a rate of return on a bond investment is not different from calculating a rate of return on any other investment, just like owning a restaurant, for example, and then you decide, okay? So let's go and do it. Okay. So here we can summarize what you did here. We said you bought a restaurant on January 1. So we're just going to say PT is a purchase price. That's a price today when you bought the restaurant, price in January 2025. You paid $200,000 for this restaurant. Okay. And then throughout 2025, you made a profit equals to $20,000. And then after 1 year, you write this as PT plus 1. Today plus 1, that means 1 year after today, because you got rid of the restaurant towards the end of the year, you sold the restaurant for $250,000. So A, the rate of return on an investment is a percentage change in the price level when you sell that investment. So the percentage change is what we in the price of an asset is a rate of return. It's on the rate of capital gains. I mean the rate of capital gains is a percentage change in the price of an asset. So you're gonna say rate of capital gain you're gonna take the selling price. You sold the restaurant at the end of 1 year, but you subtract from it the price you purchase it, divide by the price you purchase it for. That's how we calculate the percentage change in the price, which in this case is gonna be you sold the restaurant for $250,000, but you purchased it for $200,000. Then divide by the purchase price, which is $200,000. So your rate of capital gains here, 250,000 minus 200,000, the numerator is going to be $50,000. Divide by $200,000. So the dollar sign cancel. These zeros cancel. So you get 5 divided by 10. 5 goes here, 1, 5 goes here. How many times? 4 times. So this is 1/4, which is 25%. So that means your rate of capital gains equals to 25%. Because 1/4 is 25%. Okay, so B, the rate of return, as I say, the return on this investment, or you can just call it the rate of return. We can just breathe it and say RET, return on this investment. You are going to take the payment that accrued to you when you own the restaurant for 1 year. you made a profit of $20,000. So that's going to be the payment that accrued to you when you own the restaurant for 1 year, expressed as a percentage over the purchase price, plus the rate of capital gains, because you see, which we already got the second part over PT. So that means your return is going to be the payment which you receive from this restaurant after, after 1 year selling food. You got a profit of $20,000. We've been told that. So the payment is the same thing as profit. It's $20,000. You're going to divide that by the purchase price of the restaurant, which is $200,000. Plus, you already got this part to be 25%. We don't need to calculate that again. We just the rate of capital gain portion. So that means your return is going to be equal to, this is going to be, this cancel, 1 over 10. It's going to be equal to 0.1, which is 10%, plus the 25% here, because it has two components. So that means the return on this investment is going to be 35%. Okay. Now, let's discuss a little bit another example that you see, because I want everybody to understand, even without a bond investment, you're just investing money on anything. You can invest money in real estate. You can invest money in a restaurant. You can invest money on different types of assets out there. Okay, let's talk about people like flipping homes. Let's talk about example two. You can say, suppose you purchase a house in Austin for $500,000, $500,000. Okay, with cash, and rented it out at a monthly rent of let's pick up a number, $3,000. And then we say after 1 year, you decide to sell the house, which we also call flipping. When you hold the house flip the house, sell the house for $550,000. So Roman part A, calculate the rate of capital gains from this investment. B, calculate the return. Okay, so it's the same idea. Okay. So the solution here, you got to summarize what you're in that word problem. So the question is saying that you purchased a house. So the purchase price was $500,000. That's $500,000. And then you held onto the house for only 1 year and sold it so that's PT plus 1 for $550,000. But throughout the year, you got a payment, which was the same thing as, that's a rental payment to you, to your pocket. You were charging $3,000 a month, but you held you owned the house for 12 months, for 1 year. So 3,000 times 12, that means you got a rental payment to your pocket equals to $36,000. Okay. So part A, the rate of capital gain from this investment, capital gains, formula is the same. You take the selling price, you sold the house after 1 year, minus the purchase price today, divided by purchase price today. So your rate of capital gain is going to be equals to 550 minus $500,000 divided by $500,000. So this is going to be, the numerator is going to be $50,000 divided by $500,000 dollars. Dollar sign cancel, zeros cancel here. So you get 1/10. So that means the rate of capital gains is going to be 10%. That's right. So what about the return on this investment? Return has got two component parts. You're going to take the rental payments that you receive from this house when you rented it out for the year. Rental payment expressed as a percentage of the house purchase price plus the rate of capital gain, which we already found to be what? 10%. So your return on this investment is going to be, rental payment was $36,000, but you have to express that as a sheer percentage of the house purchase value, which was $500,000. Plus the 10% here. We recalculate this 10%. So this cancel this, or the 36 divided by 500. Get a calculator here. $36 divided by 500. So this part is 0.what? Is 7.2%. Z is 0.072 in decimal, which is the same thing as 7.2%. Then you add to this rate of capital gain 10%. So your return is 17.2%. Okay, so now let's go back to the bond investment. Now that you know how to calculate rate of capital gains, we're talking about coupon bond. So the formula for coupon, because when you buy a coupon bond, remember, let's say it's a 10-year bond, and suppose you did not hold it until maturity, you sold it, there's going to be a rate of capital gains. So after 1 year, you're going to get a coupon C. C is it could be $100. So that means the return on a coupon bond or on a bond investment, you take the coupon payment, expressed as a percentage of the bond purchase price, plus the rate of capital gain, which I'm writing in PT minus 1 minus PT plus N minus PT over PT. The second portion is the rate of capital gains. So if you bought a 10-year coupon bond and you sold it after 1 year, after 1 year, let's say the coupon rate was $100, the coupon payment was $100. And let's say the bond's purchase price was $1,000. So the first part, if you sold it after 1 year, this is going to be 100 divided by the purchase price times the rate of capital gain, because you're going to be selling the bond perhaps at a price that is different from the price that you bought it for. If you sold it after 2 years, this coupon payment would be $200 because every year you get $100. So after 2 years, that C would be $200. If you sold it after 3 years, this coupon payment C would be $300. Because those are the total payments that you would have received thus far after 3 years from holding this coupon bond. Okay? So I hope there's an example here which we can do to, no, I don't have it here, but let's craft one. Okay? So example, suppose you purchase a coupon bond at, let's say, a 10% coupon bond for $1,200, but the bond has a face value of $1,000. Okay. It says suppose you purchase a 10% 10-year. Let's put this other word 10-year there. So that means a bond matures in 10 years. Okay. If you decide to sell the bond for $1,400 just after 1 year, calculate the rate of return. Sorry, the rate of capital gains first. And then B, calculate the return on this investment. So it's going to be the same idea. So let's summarize here. Always when you're doing this word type problem, make sure whatever you read in the word problem, summarize it. So you purchase the bond for $1,200 and you turn around and sold it after 1 year. So PT plus 1 is $1,400. Okay. We have been told that the bond has got a face value of $1,000 and the coupon rate is 10%. 10% is the same thing as 0.1. 0.1. So that means the coupon payment on this bond is going to be the same thing as little c. You know how to calculate this from our earlier discussion yesterday. You take coupon rate times the face value. So the coupon payment would be 0.1. The coupon payment is expressed as a fraction, the coupon rate multiplied by the bond face value. So you take 0.1, 10% times the bond face value, which is what? $1,000. So this bond pays a annual coupon of what? $100. Okay, so now, Roman A, the rate of capital gain. You take the selling price of this bond, PT plus 1, minus the purchase price, divided by the bond's purchase price. So your rate of capital gains here is going to be what? This is going to be equals to, you sold the bond for $1,400 after period 1, but you purchased it for $1,200 today, divided by $1,200. So this is going to be the numerator, 1,400 minus 1,200, that's going to be $200 on the top, divided by $1,200 at the bottom. So this dollar sign canceled. So you get this 1 over 6. Okay. So 1 over 6 is going to be what? What's in percentage? 1 divided by 6. That is 16. So that is 0. 1667. So your rate of capital gains in percentage is going to be 0.1667, the same thing as 16.67%. That's your rate of capital gain on this investment. Then the second part, we need to calculate the rate of return. We got to calculate the return on this bond investment. Okay? So the return on the bond investment, you're going to take the coupon payment that because you sold this bond after a year, you would have received a coupon payment, at least one coupon payment, divide by the purchase price plus the rate of capital gains, which we already figured out. We already figured out the second part. We got it 16.67%. So the return would be, okay, our coupon payment is what? Is $100. We figured it out. That's our C. So that's going to be $100 on top, divided by the bond's purchase price, which is what? $1,200. Plus, this is going to be, this part we already found it to be 16.667%. What is 1,200 divided by 100 divided by that? This is 1 over 12. What is 1 over 12? 1 divided by 12. 0.083, which is 8.3%. So that means the return here is going to be 8.3% plus 16.67%. So that comes to what? 16.67. It comes to 16.75%. No, I made a mistake here. Yeah, I made a mistake. It's not that. This is much bigger than that. So it's 8.3 plus 16.67. That comes to 24.1? 24.97%. So that's your return on this bond investment. 24.97%. It's pretty straightforward. Okay, so that is how you calculate the return on a bond investment. Okay, now, okay, keep in mind, okay, so let's stare back at this formula again. What did I say? So if you write the return equals to, we know to get a distinction between the return on a bond investment and the interest and the yield to maturity. We know C over PT technically is a what? This is your interest rate on this bond. Okay. So this is going to be plus what? PT plus 1 minus PT over PT. I write PT plus N here. And if N is 1, that means you sold the bond after 1 year. If N is 2, that means it's going to be T plus 2. That means you sold it after 2 years. If N is 3, that means you sold the bond after you held onto the bond for 3 years. So, 1. Because, okay, first of all, this part here, C over PT, what is C over PT? That's the same thing as the interest rate, the current yield on the bond. So ideally, okay. Okay, this. Okay. So first of all, Okay. So we want to find out, why is this blocking this? It's gonna wear astray. Okay. So if the return, forget about that. So if the return is written as C over PT plus PT plus N minus PT over PT. We know DC over PT is the same thing as what? That is your current yield on the bond. That's the interest rate. Then this is the rate of capital gain. And you can abbreviate this, PT plus N minus PT over P. You can call it G. So that the return is going to be equal. You can just write it as I plus G, just for short. So G would be your notation for the rate of capital gains, which is this second portion. I is the same thing as C over PT. So if you hold the bond until maturity, let's say you bought a 10-year government bond, and you hold it up for 10 years until maturity, the rate of capital gains is 0 because you never sold that bond. So the rate of capital gain is irrelevant in determining the return on a bond investment if you held the bond until maturity. Okay? So if you hold the bond till maturity, G is going to be 0, rate of capital. So that means the return on this bond investment is all going to be equal to the guaranteed interest rate on the bond. So let's say you bought a 10-year US Treasury bond, okay, with a yield to maturity of 10%. If you held that bond until maturity for 10 years, your rate of return on this investment is going to be 10%. 10% as a share of your purchase price. But remember, the interest rate is cumulative over time. So that 10% is going to be accumulating every year. Okay? That's what it is. So this part, the rate of capital gain portion is only relevant when you sell the bond before it matures. And then another thing that I want you to let you know, if the interest rate on the bonds are very volatile. They change every day or even by hour. So if you buy a US Treasury bond today, 10-year US Treasury bond today, and he says that the interest rate on it today is 10%. If you decide to sell that bond next year, when the interest rate next year may not be 10%, it might be 15%. You are not going to get paid 15%. Why? Because you signed in the contract that you bought the bond for 10%. But the implication is that if interest rate goes up to 15% and you try to sell the bond tomorrow, because we know there's a negative relationship between the interest rate on a bond and the price on the bond. If interest rate rises, the bond price is going to fall. So that means if you buy a bond today and the government guarantees a 10-year bond, the government guarantees you 10% interest rate. And then next year, you decide to sell the bond when the interest rate has gone up to 15%. You're going to be, your rate of capital gain, this second portion is going to be negative because the price of that bond next year is going to be less than what you purchased it for because the price of the bond falls as interest rate rises in the economy. Okay? So bond prices are highly sensitive to changes in interest rate in the economy. We call it the interest rate risk when you're holding bonds. Okay? Let me repeat that again. If you buy a 10-year government bond today with a guaranteed interest rate on 10%, if you sell it next year, decide to sell it before it matures, when interest rate has gone up to 15%, first of all, you don't get paid 15% because you sign a contract for 10% today. So if you sell that bond tomorrow, you're going to be selling it at a price that is lower than the price you purchase it for. Because what happens is that when interest rates rise in the economy, the bond price is going to fall. And the converse of what I said is true. If you try to sell the bond next year before it matures, when interest rate has fallen, let's say you bought it today when interest rate was 10%, and next year the bond interest rate falls to 8%. that means the price of that bond would have gone up. That means the rate of capital gain here is gonna be positive. So you're gonna make money twice. You're gonna make money on this portion here, and of course, after a year, you would have got coupon payments expressed as a percentage of the bond purchase price. So what does that mean? The rate, even though interest rate on a bond, because this first portion is interest rate, even if the interest rate the bond has got substantial interest rate on it, when you buy it, if you sell that bond before it matures and the price of the bond had gone up, this G could be way negative. Even though this is positive, the negative sign here can outweigh the positive sign here so that your return can still be negative. You can still make a loss. Okay? So it just depends on the direction of the price movement. So let's look at some of these few distinction between price. So that's what I'm discussing here. So the return equals to the yield to maturity only if the holding period equals to the what? The time remaining to maturity. That's true. That's what I already talked about. Because if the holding period equals to the time remaining to maturity, that means you held the bond till to maturity. You never sold the bond. If you don't sell the bond, that's the same thing, the point that I mentioned here. If you hold the bond until maturity, the rate of capital gain is 0. So your return is going to be equal to the what? To the guaranteed interest rate on that bond. The return equals to the time to maturity. A rise in interest rates is associated with a fall in bond prices. That's true because bond price and bond interest rate move in opposite direction, resulting in a capital loss if time to maturity is longer than the holding period. That's true. If interest rates rise and you try to sell the bond before it matures, there's going to be capital loss. The rate of capital gain is going to be negative because the price you're going to be selling the bond would be less than the price you purchased it for. Okay? And the more distant a bond maturity is, the greater is the size of the percentage price change associated with an interest rate change. What do I mean by that? So if you have different types of bonds, like a 2-year bond, 3-year bond, 5-year bond, 10-year bond, up to 30-year bond. If all of you bought these different types of bonds with different maturity, let's say I buy a 5-year bond, somebody else bought a 10-year bond, somebody else bought a 30-year bond, somebody bought a 5-year bond, somebody else a 1-year bond. If all of us decide to sell these bonds next year before their maturity and interest rate goes up, the bond with a longer term maturity, like a 30-year bond or a 20-year bond, will suffer huge losses, capital losses, than the bond with shorter term maturity. In other words, the price of a longer term bond rises more with any given change in interest rate, more than the price of a what? A shorter term maturity bond would change. I'm going to show you a table here shortly. So interest rates do not always have to be positive, as evidenced by recent experience in Japan and South countries. So let's talk about, and then the more distant a bond matures, the lower is the rate of return that occurs as a result of an increase in interest rate. That's right, because return is part of, capital gains is part of return. If you're already suffering huge losses because price went up and you sold your bond for a loss, that's going to have an effect on the return on a bond investment. So even if a bond has got substantial interest rate, its return can still be negative if interest rates rise. So let's look at this table here, which clarifies everything. So this table is saying that exactly what I talk about, that a one year return on different maturity 10% coupon rate bonds when interest rate rise from 10% to 20%. So let's say there were 5 investors. One of them bought a 30-year bond, one bought a 20-year bond, one bought a 10-year bond, one bought a 5, one bought a 2, one bought a 1-year bond. And let's pretend this is not always true. Let's assume that, because I'm doing a simple calculation, let's assume that the initial current yield, when we all bought this bond on January 1, 2025, the interest rate on those bonds were 10%. That's not true. The interest rate on different maturity bonds are different. But I'm just, for an example, I'm assuming that they're the same. And I'm also assuming that the price of each of those bonds was $1,000. This is also not true in reality. I'm just illustrating an example. The price on different maturity bonds are always different. Bonds of different maturity are always different. But we are constraining it, them here to be the same, and interest rate to be the same. And now let's say next year, interest rate rises from 10% to 20%. So it's 20% next year. This year, when we bought it, it was 10%. And let's say all these investors who bought these different types of bonds decide to sell those bonds next year. So you see column 4, this is like your price PT plus 1. Price after 1 year. This is price today when we all purchase those bonds. So you can see the investor who purchased a 30-year bond, the price of that bond is going to drop from $1,000 to $503. And the rate of capital gain is going to be negative 49.7%. How do we get that? You know the formula. The rate of capital gains, G, is given as you take PT plus 1 minus PT over PT. You know that already. So for 30-year bond, the purchase price was $1,000. But once interest rate went up to 10% or 20% next year, and you try to sell that bond, the selling price would be $503 minus the purchase price, which is $1,000, divided by $1,000. If you do the math, that is going to be equals to negative 49.7%. And the guy who bought a 20-year bond that matures in 20, if this sells this next year, that's the price they're going to sell it. Because interest rate went up, the bond price will fall to 516. So they're going to have a capital loss. Capital gain is going to be negative. We can call it capital loss of 48.4%. And so on and so forth. The guy who bought a 10-year bond, if he sells it, okay. So now you can see, that's what we say. If interest rates rise, okay, the bonds which have got longer term maturity suffer substantial price decline than bonds that have shorter term maturity. Like see a 2-year bond. You bought it for $1,000 and interest rate went up from 10 to 20%. So the price is going to drop only to $917. So you have only lost 8.3%. But the guy who bought a 30-year bond, the rate of capital gains negative 49.7%. Almost a half of the value of the bond has been chopped off. And the guy who bought a 1-year bond, because a 1-year bond means you hold until maturity. Remember, when you're holding a bond until maturity, the rate of capital gain is 0. That's why you see this is 0. Because it's a 1-year bond. We're saying that both of these investors are trying to dispose their bonds next year. But if you're holding a 1-year bond next year, that means you have held the bond until maturity. So the rate of capital gain is 0. And the last column, this is a column for return. Remember the formula for the return on a bond investment. You're going to add what? The guaranteed interest rate, the current yield on the bond, plus the rate of capital gains. So the guy who bought a 30-year bond, remember, they were promised to pay them 10%. So you're going to earn 10% plus the rate of capital gains, which is this guy here. So 10% plus negative 49.7%. The rate of return for that investment is negative 39.7%. The guy who bought a 20-year bond, you know, the rate of return is going to be the guaranteed interest current yield, which is 10% plus the rate of capital gains, which is negative 48.4. So that they're going to get a return of negative 38.4%, and so on and so forth. So you can see the people who are making money is going to be the person holding a 2-year bond, because they're guaranteed to pay to be paid 10% on interest rate, but the bond only suffered negative 8.3% capital loss. So when you add 10% to negative 8.3%, they're making a profit, or what? Their return is 1.7% positive. And the person who bought a 1-year bond, their return is going to be equivalent to a guaranteed interest rate yield on this bond, because the rate of capital gains, G, is 0. So it's going to be 10%. That's why you see it. So that's what we're talking about. So prices and returns for long-term bonds are more volatile than those for shorter-term bonds. Long-term bond prices are more vary a lot for any given change in interest rate. There's no interest rate risk for any bond whose time to maturity matches the holding period. So if you're holding a bond until maturity, you don't have to worry about interest rate risk, because you never sell the bond. You're going to get all the cumulative interest rate throughout the life of the bond. That's it. That's it for the bond. Then the last thing I want to talk about here before I head out here, the distinction between nominal interest rate and Real interest rate. So when you go to the bank to borrow money, the bank is going to charge you an interest rate. The interest rate that the banks quote when they say, so you bought a $2,000 loan, the bank says, we're going to charge you 10% APR on that loan. That is a nominal interest rate. That interest rate makes no allowance for inflation, does not adjust for inflation. The real interest rate is a real deal here. So I want to see, do I have the, I want to see the notation. What did I do here? Let me share it again. Okay, so when we're talking about the distinction between real interest rate, so we're going to notate the notation for real nominal interest rate. We're going to put I. So I here, this stands for I. And then our notation for real interest rate is going to be I with a superscript, what? R. So the real interest rate is the inflation adjusted interest rate. Okay. So real interest rate, there's a relation. So when we say in this class, pi is going to be our notation for inflation. Okay, we saw that in chapter 19. So the real interest rate, or IR, equals to nominal interest rate minus inflation. Because the real interest rate adjusts for changes in the price level or adjusts for inflation. Or you can make I the subject. You can write this as I, add pi to both sides, add inflation to both sides, and nominal interest rate equals to real interest rate plus inflation. You can also make inflation the subject by saying pi equals to nominal interest rate minus real interest rate. So any of these three formulas mean the same thing. You just wrote them differently. So let's discuss a little bit. So if the banks are giving you a loan, let's write the real interest rate formula because that's what the banks are looking at. Real interest rate equals to nominal interest rate minus inflation. So you go to the bank and the bank says, we are loaning you money, but we're going to charge you 10%. That quoted interest rate is what we call the nominal interest rate. The bank knows that if you pay them back that money after 1 or 2 years, they are not making 10%. Because after 1, 2 years, inflation, prices of goods have gone up. So the value of the money you're paying back to the bank has gone down because of inflation. And the banks already know how to estimate this. They might say after 1 year, inflation could be 3%. So the bank knows the real return on this investment or the real interest rate is just going to be what? 10% minus 3%, which is 7%. They know already. They know they're getting only 7%. Banks do that. Okay, so there are two types of real interest rate. Go back here. I want to open a slide and explain on it, the other side. Close this. Keep that. Why do I do that? So let me share my screen. Okay, I want to create this. Okay, so there's a difference between, because we're saying, okay, now if we say pi, inflation, this pi here, this stands for inflation today or inflation yesterday, past inflation. So this inflation is known by the public. Market knows it. Everybody knows it. But inflation next year or 2 years from now or 3 years from now is not known. We just predict it. So we're going to define pi to the e. That's what we're going to be calling expected inflation. Expected, or you can call it future inflation or predicted inflation, mean the same thing. Or you can even call it forecast inflation. So in that, this is future inflation. Inflation tomorrow is not known, but it's expected. It's predicted by the what? By the market. So if you are I work for a bank, Capital One, we used to do this prediction. If you own a bank and you're charging interest rate based on today's inflation, you're not doing a good job. That you're giving somebody a loan today and you're trying to figure out how much the bank is going to earn when you paid the bank back in 5 years. But we are basing that lending on today's inflation. That bank may go out of business. They're not doing a good job. Why? Because the relevant inflation necessary for this loan is inflation after 5 years, which is predicted, which is not known. So that means there are two types of what? Two types of real interest rate. One is what we're going to be calling exposed real interest rate, which is based on today's inflation, today's or past inflation. Today's inflation and past inflation, they are known. That's what we said. So that means the real interest rate formula for that exposed inflation is going to be written as is nominal interest rate minus pi. This is what we're going to be calling exposed real interest rate because it's based on non-inflation, inflation today. But as I said, the most relevant interest rate that is used for determining interest rate on a loan is what we call ex ante, real interest rate. So this is calculated based on what? This is based on future or predicted or forecast what? Inflation. This is more relevant to the bank. The bank is going to hire statistician who are going to give them prediction on what they think future inflation next year, 2 years from now is going to look like. So that now the real interest rate here is going to be, you take nominal interest rate minus expected inflation or future inflation. This is what we call ex ante real interest rate. This is the most what? Most relevant when banks give out loans. Okay. So I wrote this formula. So I wrote this formula based on expected inflation. But remember, this formula can be written in what? In two different ways. This is what? Nominal interest rate equals to real interest rate plus expected inflation. Or you can write it as what? You can make IR a subject, the real interest rate equals to what? You subtract expected inflation from both sides. That's going to be nominal interest rate minus expected inflation. Or you can make expected inflation the subject by subtracting real interest rate from both sides. So you can write this as pi to the e equals to I minus IR. Okay. So let's look at the numbers. So that means, okay, so inflation is a very good predictor of interest rates in the economy. Because when inflation is rising in the economy, banks are going to charge higher interest rate to recover the value of the money that is lost due to inflation. So this is from 1950s to more recent time, the trajectory of the US nominal interest rate, which is a blue line, So that's the blue line is what we are calling I. I with the, and then the what? The red line, that's the what? That's the estimated real interest rate. That is IR. Meaning that the gap, the difference, the gap between the blue and the red line, that is inflation. Because inflation, we say you can write this formula as pi, expected inflation is nominal interest rate minus real interest rate. So the gap between the blue line and the red line measures inflation. So you can see that inflation was the highest in America in the 1970s going to the early 80s. See that? Because nominal interest rate, can you believe average interest rates in America, interest rate that banks were charging peak at 16%. The highest inflationary episode almost in US history happened in the late 70s and early 80s. But if you look at it this way, around this time, around that time, like in the 1980s, real interest rate was -4%, was -4%. But nominal interest rate was positive 16%. So that means inflation in America at that time was 16% minus 4%. Minus is a positive, so that's going to be 20%. So inflation in America in the 1980s was about 20%. That's the highest inflationary episode in US history. Okay. So that concludes my discussion of chapter 4. So you have 2 recordings for chapter 4. One I recorded 2 days ago, yesterday actually, and then today. So make sure you watch both videos for chapter 4 recordings before you do your homework 2, which has already been assigned at Canvas. And then I'm going to record material of chapter 5 tomorrow. In fact, homework 2 combines material of chapter 4 and chapter 5. I'll make the homework due on Saturday night, both the homework and the quiz. But if there's a way you can complete both assignments on Friday evening, that would be fantastic, because then you free up more time to study for the exam on next week on Monday. I'm going to be posting the review sheet for the exam at Canvas by the end of the week around Friday. And I'm also going to post some practice questions that might be similar to what you see on the test. Okay? But make sure you're keeping up with whatever, with the material by watching those videos. Okay, I'll see you guys another time. Thank you. Bye-bye.